All right, we are back again with the some more Quicksort fun. Actually, I didn't test my audio. Is my audio working? Yes, it is. I can see it right there. Let's go. All right, so where did we leave off? Right here. So this right here is not being done, not being sorted right. So 83 is our pivot. Left, right. Right needs to be swapped. Left does not. Left advances. No swap, no swap, no swap, no swap. Has to swap. So 91 and 55 swap here. So we get 91 over here. 55 is in its place. So now left advances. Right advances. Right needs to be swapped because it's greater than 83. Left does not. So left comes up here. And now they equal each other at 92. So that becomes the pivot point because when it comes in here, left and right are equal. Pivot is not greater than left, which is 92. So it goes here, less than or blah, blah, blah equals. Then they swap. Pivot index should be 0. Comes left is 92. Okay, yeah. So those swap in place, or yeah, 0 equals nums left 92. So that goes over to 92. Then it returns right, which is the same, or 9, 8, which is 8. And then it starts back. So 92 would be over here now. 91's on the end. It comes back and it sorts left, calls quicksort on left. Right is here, left is here, left is incremented. Or no, 92. Yeah, because this becomes 83. So now the pivot is 92. Because we're sorting the left from here down. And this is never touched again. So 91's on the end. 83 is here. 92's down here. And then at some point, so I don't see any of these numbers are going to be greater than the pivot. So I don't know how it ends up right here though. Let's take a look. That's there, it's attached. Where's our break point? Don't have any. Oh. Oh man, I hit the wrong button. Oops. Oops. But yeah, see how it ends up? So 92 ends up back here. Left just keeps advancing. Same thing. Now left is 91. It needs to be swapped. So they get swapped. Go back. Oh, see here 92, 55. Got swapped. So now left is at 7, 8. Right is on 8, 9, 8, 7. So now we're 67 and 92. Neither one of these need to be swapped. See, now left is past 7. So now we set the pivot. Left does not equal right. So 7 is, or left is 92 and right is 67. So really, instead of left minus 1, it should just be right on that. Right here. Which we were saying left. This is where I removed the minus 1, I think. I think that's what I did. I think that's where it was. And that is a mistake. 92 shouldn't be there. Let me see here. But the 92 comes back to here. See, the 92 gets swapped with that. So it ends up here, out of order. And then the 92 gets swapped somewhere in here to its final place, which really should be this. Numbers right is 67. Pivot is 83, so this will exchange that. Pivots here. See, here's the thing. Everything over here is greater than that. But when we do the right side, this should get caught in this code here. Right here. If right minus left, oh no, it gets right here. This is why it doesn't do it. Because if this is the partition, when we come back and do the right side, 92, 91, if that's the case, I don't know. Let's see if the pivot ends up being 7 when we come back. Because this is the left side. 0 and 7. So that's on 1. 46. So 79 needs to be swapped. And 57 too. 79 and 50, or 55. Eighteen needs to be swapped. And 1 and 18. It's another even. So Pivot is still 5. So we're still on 18. So 46 needs to be swapped. So right is going to increment or decrement. 46 still needs to be done. This one needs to be swapped too, so 46 and 1. 46 and 1 oil. $55 and 21. 55 needs to. So left needs to swap. So right decrements to 2. Now they're even. So pivot is 18. 55. So those don't have to swap. Or actually, it still swaps. It's just where at. Pivot index is 0. So num 0. So those swap. So now pivot is 2. 0, 1, 2, which is 18. So we're still quick sorting left. So num's left and num's right. So 0 and 2 swap. 1, 2, so 0, 55 and 18 swap. Didn't we just swap those? So everything's in order here. Left is greater than right. If it's 18. Comes right as 1, so those swap. Now we're back to left again. Pivot is 18. So we go in here, that's less than 2, so it returns. Now we quick sort the right. So 1 and 2. 1 and 2. There. So we just return. It's 2 and 5. Pivot's 18. Left is 55. 67. So 3 is less than 55. 21 and 67. So nothing needs to be swapped there. Now they're tied. Place the pivot. So 46. It's greater than that, so they swap. Pivot's 4. Now it does the left side of that. left side here. So now it gets caught in this. Left is less than. So it's greater than, but it's not, it's less than. So pivot again with 2 and 4. Okay, neither one need to be swapped. Another left is greater than right. So place pivot. Pivot is 46. Left is 4. 0, 1, 2, 3, 4. So pivot is less. Oh, num's right. Greater than num's right, which was 3. Yeah, so those switch. So pivot is 3. Which is here. Left again. Turn. Quicksort on right. 3, 4. Turns. 3, 4. We got 4 and 5. Pivot. Left, right. Neither of them change. Okay, now we're at 5 and 7. 3, 4, 5. So 83 and 67. And pivot is 21. So they're both still above it. But it equals 2. So 67 and 83. They don't need to swap. Partition left and right. 5 and 7. Now pivot is 67, 987. So 79 and 83. Neither one of those need to be swapped either. $79, $83, both of them are above the pivot. So now they're even. And they're both at 6, which is 79. Okay, we need to get past this. So why did it switch on that? Why did it do that? Didn't it switch those? Dang it, I wasn't paying attention. 5, 6, 7. Turn. So 6 and 7. 8, 7, 6. 6 and 7 here. See, it looks like it swapped. Wasn't 79 already over here? Dang it. Gotta go back and do it again. Oh. What makes it tedious is you're looking at the same thing over and over. And then you get complacent and you miss it. Oh man, so we're at the very end of this. I'm gonna go set my breakpoint here. That's it. Go to there. Oh, I need heat. All right, lay down, baby. Lay down. Don't hit the keyboard, mister. I'll knock you out. Ugh. Get Brat. My dog, he's waking up. Now he's all trying to get all over me now. Here, boo boo. All right, don't break the cord. You have anything to say? Got anything to say? Do you know the answer to Quicksort? Hmm. Oh, all right. Oh, all right. Attach. All right, let's get in this. So what are we doing here? Yeah, see here, see the 67 and 79? They're already in play. So these were swapped before I just ended that session. So definitely. So partition 2 and 5. So our pivot's 18, 2, 5. Okay, let's get this sucker going. Another even. Pivot is 55. Nums left was what, 18 or something, I believe. 2 and 4? 0, 1, 2, 3, 4. No, it's not. So they don't swap. Twenty by 55. Those are already in place. So just increment those. It's not, so greater than right. It's 46, 4 and 3. Right is 21, left is 55. So it should exchange with right. Comes right, yes, it is. So those exchange. And it returns that. Goes to left. Left shouldn't be doing anything. Returns. Now we quicksort right. 3 and 4. That returns 2. 4 and 5. Pivot's 46. Got 55 and 67. So that shouldn't do anything. Then we go to right again. 0, 7. Oh, man. So that equals 2. So pivot is 21. Partition left and right. Just 5 and 7. 7983. So the 79 needs to go over to the right. So that means the right is going to decrement there to 6. Now they're even. Place pivot. Pivot 67. Greater than nums left. Which is 6. They're both 9, 8, 7, 6. So 79. So 67 is not greater than 79. So that should not go there. It's not going to exchange with left. Okay, here it is here. if pivot is less than nums left. Look at that. It's the exact same thing. Pivot index equals nums left. Pivot index equals num left, num left there. That's why the 67 changes with 79. I mean, the pivot doesn't need to be swapped. I mean, it is 6, right? Yeah. 6 and 6. Left and right are 6. Pivot index is 5. Yeah, these don't need to be swapped. Less than nums. Why did I put this when I could just say less or equal? Why did I write that logic, though? I mean, it had to be the case where... See, if it's greater than right, it always swaps with the less of the two, but... So now I'm thinking... It doesn't need to swap. This doesn't need to be there. But why did I put it out? I would have put it in for something. There must have been an edge case. But I can't think of it. Alright, let's stop this. Because they're equal. That makes no sense. There had to be a logic change there for some reason there. Also, this should have been consistent. The right, I should change that to return left since they're equal. Left and right are equal. That needs to be consistent. This too. This is the same stuff. Needs to be consistent. There had to have been an edge case somewhere where I added that. And plus, this shouldn't even be here anyway. It should just been the less than or equal. Right there. So... I mean, that was that one case, but it doesn't explain this unless it was the same bug. If that was even a bug. Yeah, see, so I must have put it in there because... because it doesn't... So what was the real logic on it, though? arm's length. Why would it be the same thing? Else, if it's less than or equal, then this must be the wrong one here. It flipped it. So 67 was less than 79. Because that one makes sense. This one makes sense, but else, what would be the difference though? 67 and 79 else. Turn left. We could just not do it in return. Maybe we could return the pivot position being the same thing. Let me see that. Just keep it the same. Hmm. No, it still goes into the infinite loop. Okay, so this is early on when we're doing the left side and it's doing some of the right stuff. So we've got 2 and 2. 0, 1, 2, 55. That's the same. So the 18, because pivot wasn't greater than 18. But in this case, it did swap them out and return that position. Uh, So it fixes that one thing, but I still got the 92 to deal with. So should there be another one here? If left is greater than right. Because otherwise, if pivot does not, I don't think it has to that point. I don't know, let's try. No. So now we got to deal with a 92. Oh, never started it. Okay. So let's go there. That's on that. We don't need that. Back here to our right. Where are we at? here. Let's see where we're at. 2 and 4. That's not it. 2 and 5. We're still on the left side then. 0 and 5. 0 and 7. Okay, 5 and 7. Now we're on the other side. 0, 1, 2, 3, 4, 5. So 67 and 83. So we know this code does it, or is correct. One more. 0 and 7. That's definitely not right. 0 and 9. Okay, there we go. So 7 and 9, pivot of 8. 9, 8, 7. So here we go here. The pivot ends up being 92. And then we have 83 and a 91. So the right needs to be changed. Let's go into this. But nothing happens because it returns. So maybe this is the problem. Because there's definitely work to do. Maybe I shouldn't have these little micro optimizations here. Maybe I should let it go. So if right minus left is, I mean, that's all it's going to do. Right is 9. Yeah. Wait, what is that? No, right is 9, left is 8. Yeah, and then pivot is that. So pivot's 83, right, left. Yeah. These need to be swapped. And I know there's code in there to do that, but it's here in the partition, isn't it? No, it's here, right? Position. Else if left is greater than right. So there's no code after that. So either way, that's not getting hit. It'll never go into partition because it's not getting past these guards. So if we call partition with this, 92 and 91, index would be 92, or the pivot would be 92. Then these would equal each other, left and right, because that would increment. So it would go down here, place pivot position, and pivot is greater than that. Let's try that. It looks like it'll do it, but I don't know how that affects other code. If it does, then this is really just janky and brittle code and would really need to be just redesigned. So let's do that. In this case, we are swapping two values. I think that needs to stay. Let's go here. That. Quick sort there. Now we're still in some kind of code where it doesn't. Okay, let's take a look at this. See if anything. Well, no, it wouldn't. It wouldn't do that. That wouldn't lock it up. So the only real loop we have here on left and right, which if it never returns from the, let's see, last thing we did was this, so it's probably in that. we got a good run on that. So let's put our random code back in. Whoa. Oh, we're in a loop again. Man. So that's doubles, right? Maybe we need to put the equals up here. Greater than or equals. Then go ahead and do that. Who knows? Who knows? I'm sure you guys know because you probably know the algorithm. Need to run it through those one numbers. Was it, which one was it? These? Let's see here. Let's run it through with these. These have doubles. 17, 17. Whoa. No. So, it's definitely not that. Alright, so we have to go into that. Oh. Okay, there's never a case where that wouldn't break. Oh, I didn't attach it. Dang it. Okay, let's do it again. 92 and 74. So the left needs to swap. 17. So this is where it's equal to. So right num is less than or equal. Got that one right there. So we swap that. Got 17s over here. '89 and 48. Those need to swap. Well, left needs to swap. So right decrements. 89 and 7. They need to swap. Oh. 63 and 57. Left needs to swap. So right decrements. Six, same thing. Another equal. Otherwise, it just returns left. Okay, so this is it. It was, doesn't that just leave it in the same state? I mean, the pivot is 17, but if we just return left, then we're just returning the same number. We're doing the same thing over and over. 0, 1, 2, 3. So we return 63. That's the pivot position. Which pivot was 17 right here. But that only needs to change if it actually switched. But what if we did the -1? Let's try that. So the return left fixed that one edge case, but that's just not, it's not correct. Less than or equal to nums left. Which that's this code here. This code here would have did it. But I think it would have been minus. So instead of this, oh. But what if left is 1 and we do a minus 1 on this? Then it's 0. Didn't I already have these in there at one time? And then I deleted it because I thought there was some other edge case. At some point, I think I need to redesign it. So this one sorts correctly, but now we got the other ones that didn't sort when that was in there. And I can't remember which one that was. It was the one with the 67 and 83, I think. That was right there. So I did a bunch of testing after that. This one here. Because remember we had the 92 and 91 flipped. Right here. So these are the ones we need to sort. Should just write test cases. Test cases are really good for algorithmic stuff. Oh, what am I doing? Go here. Oh, wait. It needs to stay just as it is. All right. Do that. Do that. Everybody cross your fingers. Unless you already know what the fix on this stuff is. All right, so it still went. Got to do how many successful runs before we say it's fixed? Oh, wait. We got to do this now. How would it did like 10 times and it would have been the same result? Same thing. So surely we're going to run into an old edge case. And that's why you need the test, because then it preserves all those edge cases. So if you're not testing, test. But don't go overboard. You don't have to test like 98% of code and all that. Unless you're doing something, with NASA or something. then you probably do want to do that as much as possible. Okay, that was good. That's one good one. We need the doubles, because doubles seem to be the ones that messes it up. That's too good. I don't see any doubles in that one either. Okay, three. I do not see a double in that one either. Uh, all right, dare I say it's finally done? One more. Of course, now we can't get any doubles. We got doubles. All right, I'm calling this done. Yay! We finally did it. Yay! Wow, how many parts was that? 7 parts? All right, guys, I got it coming. I know I got it coming. Just unleash on me in the comments. I can take it. I take it. If you made it all this way, you are a trooper, and I salute you big time. I got mad respect for you. There it is, guys. Only thing left to do is clean up stuff like this. I think that was it on dead code, wasn't it? All right, guys. I am declaring that done. Yay! Finally did it. Wow. Now I got to go look at the real algorithm and see how it compares. All right, guys. Hey, like, share, subscribe, please. Trying to grow the channel. If you like watching me do this stuff, hey, awesome. I also got lots of videos of my dogs. If you're into dogs, hey, I got some good stuff out there. I'm also doing the roguelike game. You can follow that. I'm learning C++. So in the future, shoot, I'll probably learn Go, maybe Haskell, 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 Haskell. Sounds too much like Pascal. Okay. All right, guys. Thanks for coming along. Have a good day. Bye bye.